Hello and welcome everyone to this edition of our webinar series Wednesday with Quizzes. In this particular edition, we are going to cover the topic related to relative speed, especially the question related to and fro motion. So these are the questions where two bodies will be involved and they will be moving either in the same direction or in opposite direction. I also believe that you must have received a link with our concept video session where we have talked about 4 to 5 different scenarios related to this type of questions. If you haven't, then definitely you should go through that. You can find out the link of that particular video. That will be roughly around 12 to 15 minutes video in the right hand corner of this particular video. You can get the link to that. Okay. So I would strongly recommend that you go through it before you move ahead with this session. All right. Now coming to this particular session, we are going to discuss 3 questions which will be of relatively higher level compared to the questions that we have discussed in the concept video part. And that will be obviously GMAT type questions. Okay. And we'll understand how we can solve such question using the concept of relative speed and the understanding we have till now. So let us move ahead with the session. So this is the first question. So this is the first question. Before you see the solution, I would suggest that you pause the video for a couple of minutes or 3 minutes, solve it, find out your answer, and then move ahead with the solution. All right, so let us see how we can solve these particular question. So a train X starts from Manhattan at 4 p.m. and reaches Brooklyn at 4:45 p.m. While another train Y starts from Brooklyn at 4 p.m. and reaches Manhattan at 5 p.m. If they travel at a constant speed without any stoppages, then the two trains will cross each other at approximately what time? That is, I need to find out. Okay, so let's see and let's understand what is happening in this particular question. So there are two stations. One is Manhattan, one is Brooklyn. I have no idea about the distance. However, I know there is a train X which starts at 4 p.m. and reaches from Manhattan and reaches Brooklyn at 4:45 p.m. So I can understand that this particular train is taking 45 minutes, or if I want to convert it into hours, I can say it is taking 3 by 4 hours to reach from Manhattan to Brooklyn. Now there is another train which Y, which starts at exactly 4 p.m. from Brooklyn and it reaches Manhattan at 5 p.m. So I understand that this particular train is taking 1 hour to reach Manhattan, to cover the distance. Okay, so this is what is given in the information. Now let us see how I can utilize this particular thing to solve this question. Now, as I understand that X is taking 3 by 4 hours in terms of hours and Y is taking 1 hour, let us try to draw the DST table and find out what exactly these two trains doing in terms of, or what are the different variables I can find out in terms of DST for these two trains. So when I do that, I understand that train X takes, I already calculated, train X takes 3 by 4 unit. Now the distance, so obviously the distance I'm talking about from Manhattan to Brooklyn, that distance is going to be same. Let me assume the distance to be D. And that distance is going to be same for train Y, train X, and train Y. The other train, that is Y, is taking 1 hour. So as you understand, from this particular set, we are pretty clear that I don't know the value of D, but I assume the value of D, and I know T. Now, what is speed? Obviously, the relation I know is speed equals to distance by time. With the help of that relation, I can say it's going to be D by 3 by 4, or I can simplify this to be 4D by 3. Similarly, this one is going to be d by 1 or d, that is for y. Now understand, I have got what is the speed, okay? What is the speed of these two trains in terms of d? Now, how then the concept of relative velocity comes into this particular question? Okay. If you have remember in one of the example in our video, we have discussed if two trains are traveling X and Y and they are traveling in opposite direction like this, they will meet somewhere around here. We add the relative velocity, right? Because they are moving in opposite direction. Okay, so they are moving in opposite direction, so their relative velocity must get added, right? Now think about a scenario, think about this scenario when they meet. It means, can I say what exactly is happening in the system here, that the train X is traveling some distance, train Y is traveling some distance, and together they are meeting. So relatively they are together, they are traveling this distance and this distance. That is nothing but going to be the total distance between these two stations, which is d. So if I talk about a scenario, what happens when they travel together at a time, I'm basically talking about that they are covering a distance of d. In how much time I need to find out, right? Because together they will reach here, both of them will reach here, and together one will travel this distance, let it be d1, and the other train y will travel d2. So together they will travel the entire distance, right? Now what happens to the relative velocity? The relative velocity gets added when they are in the opposite direction. So can I simply say, I know the relative velocity here, I know the velocity here, so the relative velocity is going to be 4d plus d, 4d by 3 plus d. Now, once I got this particular thing, I can now clearly say that I know what is the distance in terms of d. I know the speed. Then what will be time? The formula for time is distance by speed. So definitely what I'll get here is that d divided by 4d 3 plus d. Okay, and I need to simplify it. Now, how I simplify it? You can say you can take d common and d will get cancelled out. So if I take d common in the numerator, I get d into 1. If I take d common in the denominator, I get 4 by 3 plus 1, right? So ultimately, I'm going to get something like this. If I simplify this, I get 3 by 7. So basically the time, since everything other numbers were in hours, here also I'm getting the time in hours. So when will they meet? They will meet after 3 by 7 hours, right? Now a very small calculation that is left, which is I need to convert this 3 by 7 hours in terms of minutes. So how do I convert it? I multiply it by 60. Okay, so I get 180 by 7. If I divide, it goes 2 times 40, which goes 5 times, and then I have 5 by 7. So I get exactly something like this. Now, which they ask me what is approximately the value, and I can see which value is the approximately one. It's going to be 426. So my answer is going to be this. So I hope you have understood how we have used the concept of relative velocity to this question. We have found out, we have used the DST table to find out for X. We have found out for Y. Once we found those particular scenarios for X and Y, we took a scenario when we combine them. So if they are traveling together, or if they are, if I consider the scenario when both the trains are traveling, then what will happen? And based on that, I have got my answer. Okay. So, all right. So with this understanding, let us move ahead to the next question. And as usual, what you should definitely do is that pause this video for a couple of minutes, solve this question, and then move ahead with the solution. All right, now let us see this question. So the question suggests is that a car is 40 miles behind a bus. Okay, so if I start drawing, I can say there is a car, okay, and there is a bus. And since it is behind, I can say possibly they are moving in this direction. Okay, the bus, comma, which is traveling in the same direction along the same route as car. So they are traveling in the same direction. So basically they are traveling in this particular direction, say, and the car is little behind the bus. And how much behind? It is given as 40 miles, right? Now, after how much time will the car be at a distance 8 miles from the bus? Okay, so obviously I need to find out currently the difference is 40 miles. After how many hours or how much time the distance is going to be 8 miles, right? Okay, so now, with our experience, we have found that the many students in this kind of question mark the answer as C because they are looking for how should I find out the relative velocity? Because till now, what we have realized that in this kind of question, I need to know relative velocity, right? Which is correct. You need to find out the relative velocity. Now, what is the relative velocity? For that, I need to know their individual velocity or directly the relative velocity. Either of them I need to know. Okay, so I need to know the individual one or I need to know directly what is the relative velocity. Okay, obviously for that I need to know what are the different answer options, what are not answer option, question step. Okay, uh, I will analyze this question, I mean the question step, but before I do it, I can say that if I just look at the option, the first statement gives me what is the speed of the car. Second one gives me what is the speed of the bus. So obviously, if there is anything I need for relative velocity, I need both of them. Okay, so you can straight away say just understanding this, just going to this couple of options, and even if you, although we strongly recommend we do it, we will do the analysis for this question stem. But if I just look at the option, I can definitely say that I will definitely need both the statement. There is no way I'm going to get the answer with one of the statements, right? So obviously these answer options are not going to be correct. Okay. However, there is a catch which sometimes students miss here. Okay. Now, what is the catch? We definitely need to understand in question related to time and distance, picturizing or visualizing this particular scenario is basically going to be very important. Now, see what happens in this particular scenario. The car is here, right? Okay. The bus is here. Now, what happens? The Currently, the distance is 40 miles, right? Okay, so suppose this distance is 40 miles. Now, I need to find out when the distance will be 8 miles. Now, that can happen in two scenarios. One is that suppose the car has moved along this line and the bus has also moved along this line. And currently the bus is here and the car is 8 miles behind like this. Or there could also be a scenario when the bus is here and the car is 8 miles ahead, right? So I need to be very sure about this. So what I'm doing here, I'm doing the question stem analysis and I see the distance can become 8 miles in two scenarios when the car is behind or the car is in front. Okay, and this question basically deals with this particular trap. So once you understand this particular trap, this question is pretty simple, right? Let's see how, let us still explore this one, that how answer will differ. Okay, now we you know the concept of gap, right? Now what is the gap here? If you have gone through the videos, you must know the concept of gap. So here, the car was 40 miles behind and it is now 8 miles behind. So the gap coming from this scenario is 40 minus 8, which is 32 miles. However, for the second scenario, it is 40 plus 8, which is 48 miles. right? So if you find out, if you use the formula for gap and distance and speed, that particular formula, what will need, you will need the gap, and the gap is not fixed. The gap can be 32 miles. It can also be 48 miles. So I will get two different answers. However, in DS question, I always look for an unique answer. Will I get an unique answer? No, I will need two scenarios. So once I understand, analyze this question stem, what I know, I need to not only know the relative velocity. So the question stem that comes, I definitely need to know the relative velocity. That is definitely must. And I should also know how C and B in terms of position, whether C is ahead of B or it's C is behind of B. So I need to know both of them. Now, if I obviously, by the time you have realized that if I analyze statement one, it gives me the speed of car that is not sufficient to answer this one. And this is not sufficient to get the relative velocity. So obviously I'll eliminate option A, I'll eliminate option B. And then statement two gives me the speed of the bus. Obviously, here also, I cannot get any of these answers. So I will eliminate option B as well. So when I combine, yes, if I combine, I get the relative velocity. That's there. But I cannot get the answer to this particular question, which one is ahead. Since I cannot do it, I definitely mark, say, this even combining these two statements are not sufficient. And I mark E as the answer. All right. So let us see what exactly happened in this particular question, right? So the question suggests that San Francisco and Los Angeles, these are two cities which are 383 miles apart. Okay, so there are two cities which are 383 miles apart. Miss Braid starts with a hooker. So the first person starts with, let us call it Miss B, starts with the car from San Francisco at 5 a.m. and traveling at a speed of 42 miles per hour. Okay. And there is another person, which is Mr. Garcetti. So let me call it Mr. G. That person starts at 6:30 a.m. and travels at a speed of 38 miles per hour. Okay. If they travel at a constant speed, then what time do they meet? All right. Now, obviously, I understand from this particular thing and whatever the video we have discussed in such a question, I need to find out what is that one moment when what is that first moment when both of them starts traveling, right? I need to find out what is that first moment. Now, obviously, it's pretty easy to understand that since the first person starts at 5 a.m., the second person starts at 6:30 a.m. Obviously, 6:30 a.m. is the first time when both of them are traveling. All right. So if 6:30 is the first time, I need to find out a scenario when both of them are traveling. Let us see what happens at 6:30 a.m. So till 6:30 a.m., 5 a.m. to 6:30 a.m., only Miss B, the first person is traveling. So the first person has traveled for 1.5 hours because from 5 a.m. to 6:30 a.m., it's 1.5 hours. So that person is already here. So if that person is already here, I need to find out what is this distance that first person has covered. It is easy to do because I can say it's 42 is the speed and 3 by 2 is the number of hours. So obviously I'm going to get 63 miles. Since I have already, this person has already traveled 63 miles. So at 6:30, the distance is no longer between the two people are not 383. It's actually 383 minus 6:30. So the gap we are talking about is reduced to 320 miles. And that is going to be my starting point. So if the distance is 320 miles, obviously this is the moment that is I'm talking about is at exactly 6:30. The distance is 320, B is moving as well as Mr. G, that person is also moving. right? So if they're moving in opposite direction, what happens to the relative velocity? We add the relative velocity. So what is the relative velocity going to be here? 40, sorry, it was 42. The relative velocity will be 42 plus 38, which is 80 miles per hour. Now, if I know the relative velocity with the concept we know about the gap, how can I find out the gap? I know the gap is going to be 320 miles and the relative velocity is going to be 80. So the time is nothing but gap by relative velocity, which is going to be 4 hours. Now, what is this 4 hours? This is 4 hours after 6:30. So that is very crucial. So I should definitely understand that after 6:30, when both of them are moving, after that, another 4 hours after this 6:30, which is going to be 10:30 a.m., both of them will meet. So they will meet at this point, and my answer will be D. So understand what happens in this kind of question. In this kind of question, if the time are different when two people are moving, we need to find out that one time, first time when both of them are moving, we manually come to that position, we reduce the distance or increase the distance, whatever, based on the question. And that gives us the actual gap at that particular moment when both of them are moving. We find out the relative velocity and we solve it in that way. So with this understanding, I believe most of the questions that are there, when I say most of the question, obviously there will be certain question where along with relative velocity and this kind of scenarios, some other complexity will be involved. So those kind of question obviously will need some other understanding. That is fine. Having said that, most of the question related to relative velocity can be solved with understanding these 4 to 5 scenarios that we have discussed and this kind of question we have solved today. So what I would definitely suggest you that you definitely take up the free trial option that we have, go through our course because our new course we have created the module of DST. I'm talking about the DST. You can definitely check out the other modules as well. So for distance, speed, and time, we have kind of modeled our relative velocity section around these kind of scenarios so that you are sure about, you are aware of all the scenarios and you can solve almost all type of questions. Okay, I'm pretty sure if you go through it, you will definitely like it. Okay, so I would suggest that you take up the free trial option, go through it, and obviously, if you like it, you can definitely subscribe for the other parts and all. That definitely, if there. And apart from that, if you have any queries or anything, you can definitely talk to the representative from our side. There will be a Calendly link shared. You can definitely talk to them any kind of queries you have with your preparation. Okay. And also there will be a link to our website and free trial and all these things. So these links will be provided in the comment section of this video. All right. So I hope you have understood these questions. Even if you have any question related to these topics, use the chat box of this video section. So next few weeks, we'll be regularly visiting this place and see if you guys, if anyone is putting, anyone has any doubt or anything, and we'll try to address that. Even after that, we'll be reviewing this comment section to address any of the doubt you guys have. Okay. And if you have liked this video, if you have um, you feel that in this video or any of the videos our series has helped you, definitely I would suggest that you subscribe to our channel and also press the bell icon, because if you press the bell icon, then all the newly added video, you will get the notification of that. So you can definitely check it without coming back to our page again and again. So with every video that is uploaded, you will get a notification. So I'll definitely recommend that as well. All right, guys. So that's it for the session. I hope you have liked it. All the best with your preparation. Thank you.